Hello everyone, this is Cavell, and today I am going to be talking about how to complete the square. So, we have complete the square. So in general, when we're completing the square, we are dealing with parabolas or quadratics. So quadratic equations, what do they look like? They look something like ax squared plus bx plus c equals to 0. And completing the square changes this quadratic equation into the form of a vertex. So in that case, we want to change it into something that looks like this. So you're probably asking me, well, Cavell, what's the point? What is this vertex form? So this is the vertex form. And I will go over why this is important and why this is relevant. So in the vertex form, the vertex is read off the equation very easily. And if you think about the vertex in the quadratic, it's pretty difficult to find the vertex. We have to find x equals negative b over 2a, which is the line of symmetry. And then we need to plug it in, that value into the equation, and we get a value for y. So it's a whole mess there. But when we complete the square and put it in vertex form, we can easily read off the vertex. And the vertex in this is just simply h comma k. Now it's important to realize that the equation is x minus h squared plus k. And so, for example, anytime you have complete the square, you want to put it in this way so you can read off the vertex much easier. So now let's do an example. So an example I have today is 2x squared plus 8x plus 3 is equal to 0. So the first step to completing the square is whatever constant you have, right? You want to move it to the right side of the equation. So we will have 2x squared plus 8x plus, and then we leave a blank here. We'll subtract the 3 to each side. So we'll get 2x squared plus 8x plus blank equals negative 3. So now to fill in this blank right here, we need to look at b, but there's something special about this equation. When we are completing the square, right, if the a value is not 1, meaning if it's negative 2, if it's anything besides 1, we need to divide and factor this left side of the equation by a. So in this case, a is 2, so we need to factor out a 2, and we should get x squared plus 4x plus blank. It's all equal to minus 3. So the key, as you can see, is to get this quadratic where a is equal to 1, hence why we factor out a 2. And as you can see, when we factor out a 2, we get x squared plus 4x. Now the next step is to look at this middle number, this 4x, and we have to look at the coefficient. The coefficient is the number that's next to the variable. So the number is 4, right? Next thing we do is we need to divide it by 2. And whatever that number is, we want to square it. So 4 divided by 2 is 2. 2 squared is 4. And the next thing you want to do is have this number be filled into the blank. So one key thing you want to realize is that when we're adding 4 to this left side, we are now unbalancing the equation, right? But if you realize, we're not just adding 4, we're technically adding 8, right? Because we're multiplying this whole thing by 2. So 2 times 4 is what? 8. So that means essentially on this left side of the equation we're adding 8. Then we also need to add 8 on the right side of the equation. Now, after that, we need to simplify. So now, what's cool about completing the square and convenient is that x squared plus 4x plus 4 is basically x plus whatever this 4 over 2 is squared. In other words, x squared plus 4x plus 4 just becomes x plus 2 squared, right? And this is equal to minus 3 plus 8. So now we just need to simplify the right side. So we are left with 2x plus 2 squared is equal to 5. Now remember the form we want to get this into. So we want it to look like ax minus h squared plus k equals 0, right? So we need to move the 5 to the left side, and then here's what we get. We get 2x plus 2 squared minus 5 is equal to 0, and as you can see, this isn't the form of the vertex form, so we need to change it. So instead of x plus 2, we have x minus minus 2, which is the same thing as saying x plus 2. And then the minus 5, we will change as to addition, adding a negative 5 is equal to 0. So in this case, this is the vertex form of the original equation, 2x squared plus 8x plus 3 equals 0. And as we can tell, the vertex is easily read off of this equation. The vertex is hk, right? H is equal, and if we look at this, this is h, this is k. Therefore, the vertex is -2, -5. And that's how you complete the square. So, another thing we can do is solve this quadratic using completing the square. So, let's move this. So the equation we had was 2x minus minus 2 squared plus minus 5 equals to 0. Now to solve for x, to find out what values of x will give us y equals 0, we will add 5 to each side. And then we will get 2x minus minus 2 squared is equal to 5. We divide by 2. We will get x minus minus 2 squared is equal to 5 over 2. We will square root both sides. We get x. So this whole time I've been writing minus minus 2, but I'll just write x plus 2 for convenience sake. It's the same thing. It's equal to square root of 5 over 2. And remember, when we find square root, right, there's a plus or minus. And then we are left with x. So we subtract 2 actually from each side. The answer we get is then x is equal to minus 2 plus or minus square root of 5 over 2. So notice how we have plus or minus, thus we get two answers. We get x equals minus 2 plus square root of 5 over 2. And we also have the answer x equals minus 2 minus square root of 5 over 2. So obviously with any quadratic, there are going to be two roots, and we found both of them. Alright, that's all for today, and thank you for watching. Bye bye.